Good morning, good afternoon, or good evening, depending on where you are in the world. Welcome to today's webinar, Quantification of Participation Risk using R and R Shiny, brought to you by the R Consortium. The R Consortium supports key organizations developing R infrastructure through grants and sponsorships worldwide. Please visit our website to learn all the details and how your organization can become a member. My name is Jesse Kasman, today's moderator. I have just a few housekeeping items before we begin. You can ask questions at any time during the webinar. Just type your question into the Q&A webinar window during the presentation and click the submit button. Near the end of the webinar, our speakers, Goran and Simon, will try to answer as many of your questions as time allows. Actually, Goran and Simon said that at any point during the presentation, you're welcome to ask questions. They hope that this is interactive and a starting point for more discussions. Okay, so let me introduce Goran and Simon from the Raiffeisenlandesbank of Upper Austria, our speakers today. Goran Lovrich, LLM, is a seasoned expert with over 18 years of expertise in national and international financial risk management. He holds certifications including Financial Risk Manager, GARP, and Professional Risk Manager, PRMIA. Simon Einer, MSc, is an economic and business analytics professional at Raiffeisenlandesbank. He specializes in automating internal risk management processes using R, enhancing operational efficiency and minimizing risk exposure. Goran and Simon, thank you very much. Please take it away.
Many thanks for the introduction. Let me share my screen. Perfect. Many thanks for having us today. Thanks for the nice introduction. In the following minutes, Goran and I will try to give you a little overview of participation risk with R and R Shiny, a brief case study. So let's jump right into it. What's the scope of today's webinar? We will try to focus on approaches around quantifying risks for participation. In the following minutes, we try to give you an end-to-end approach from the start to the end. So in the following minutes, the agenda looks like we will start with a quick review of a discounted cash flow approach for participations, followed by some data collections where we use APIs and/or web scraping. Afterwards, we will talk a little bit about modeling. And last but not least, Goran will show you how to put this information into an R Shiny app. And lastly, to deploy these apps or such an app in a server environment. Yeah, first things first, who is who? Many thanks for the introduction. So I think we can skip this part. You already know us a little bit and can jump right into the code, into a little introduction of the Raiffeisenlandesbank of Austria.
Thanks a lot, Simon. Much appreciated. Thanks also a lot to the R Consortium. As mentioned by Simon, maybe just a little bit of introduction around the bank and why kind of this topic around participation risk is so close to us. We're the largest bank in Upper Austria. We're one of the leading regional banks in Austria with a bit of, let's say, modern and different strategic approach than some of our competitors would have. Why? Because participations and having capital in other companies that are maybe not even banks themselves is core to a strategy. And as such, if you take a look into other European countries and countries worldwide, actually, you will find banks that operate in the same manner, diversifying away actually their risk of core banking activities by participating in the cash flows of other companies, meaning going into a more diversified revenue approach. And this is a bit also the motivation for why we are sitting here today, combining the whole participation risk topic with actually R. So if we go to the next slide, we will see that today's session wouldn't have been possible without our consortium. So a big thanks from our end, and appreciating very much the invitation and the possibility and opportunity to speak here. So great thanks to that. Now, let's jump really into the middle of the modeling itself and the setup itself. So we're talking today about participations, but let's first, maybe before we go into the code and the setup itself, let's talk about what that is. Because many of you, when you use R maybe for market risk purposes, first thing you think about is potentially the market risk part of it. But participations are a bit different to that. So if we take the legal definition, it's a right in the capital of a company, which is not very much different to if you buy shares of Apple, for example. But the big difference here is that if you have a participation there, you are more interested in the value of it than in the price. So this big concept of price versus value comes into play here. So participation risk, as the definition that we use now, is actually the risk to changes in the value, not in the price. So market risk to changes in the price of preserved prices, market prices. Participation risk, changes in value and or, because that's correlated, and we will see how, in cash flows. So with that definition, what we actually need, and what Simon is going to show us in a couple of seconds, is actually we need 3 steps to be done in order to quantify the risk. We need the cash flow information and the cost of capital or equity information. So that means, what is the company earning? How is it earning money? We will see the definition of it in a minute. The cost of capital, what is kind of the rate of return that we are expecting from a company where we have a participation, an active participation. We will need the volatility data of those variables, meaning how does it fluctuate? If we now assume that cash flows produced by, let's say, Apple are 250 billion, let's say, a year, what is the volatility of it? Is it every year the same, or do we jump up and down? So what is the expectation here? So that's what we're interested in. And last but not least, we will need to combine this information into a nice Monte Carlo simulation in order to determine the value at risk on a 1-year period, on a 1-year holding period in that case. So that's kind of the basis that we need. And the next step towards calculating it, we have actually packed for all of you into an application that we have publicly made available on JIT. We will see it in a more detail, but for now, you can definitely access already this page, and you will see that there you will find a fully functional application that we will walk through, and you will be able to use it under an open license. So if we jump into the next slide, we already gave a bit the path in the direction of what is a discounted cash flow model for the purpose of participation risk. And here we see a very, let's say, simplified approach of calculating the market value of a participation of a company by dividing the cash flow by the cost of equity. Or vice versa, if you have the valuation of a company that is provided, for example, through a third party, through observable market prices, and you have the cost of equity, you can easily derive the cash flow. So this is a 1-period model here, which is a bit of a deviation to a multi-period model with the terminal value that was presented, for example, last week in this panel by our colleague Christoph Scheuch. So it's similar approach, but here we're actually considering a 1-period model. So the big question here is, when you have this setup and you can calculate the value at risk, before you calculate it, you need to get to the data. And the data is what we will focus on today, especially from an angle of openly from, let's say, open sources getting the data and calculating with this data. So with that, I would like to hand over to Simon to walk you through the approach of scraping the data and getting the data from open sources.
Many thanks, Goran. Yes, in the following minutes, I try to show you three different approaches how we at RLB Oberösterreich actually scrape live data from the internet. In the first step, I will show you how, for example, we use the official website of the ECB to get interest rates. In the second example, I will tell you how to actually web scrape data from Google Finance. And lastly, I want to talk about a little bit different way how to web scrape data by using APIs. And therefore, I will show you the example of the Yahoo Finance page, where I show you how you can get actual stock prices in near lifetime. Perfect. Let's jump right into the code. So, as I told you, in the first step, we will talk about interest rates. And therefore, I want to talk about a super useful and very simple package called ECB. And therefore, I show you the ECB website. And here, when you go to browse data, you can get all the data you want. And I decided, for the example here, to talk about the Swenson interest rate curve. And if we look at the graph and we say, okay, we need the data behind. And we can do this in a super simple way by using the series key, which you can find on the top of each page. And if we copy this code, we can start by using the library ECB and just putting in our key and set some filter options. So the key, as I already showed you, and the filter options, which are not necessary, but here I told it, okay, I want the last 100 observations in full detail. And then the ECB package makes it super simple for us. We just have to use one command, which is called the get data command. And we simply paste in our key and our filter options. And by doing so, I can show you we get a well-formatted, super simple table with all the information we need. If we go to the right, we see our actual interest rates at the different points in time with with much more information you may or may not need. Exactly, and if we plot it, we can see here that we have a decreasing trend for the past 100 observations. So from about July to the end, or yeah, to start of December in the graph. And that's the first way, and much likely the most simple way. But now let's talk about cash flow. And I think that's much more interesting because here we use the Google Finance page and we now do some actual web scraping. If we decided for the example to talk about the Apple stock. And if you are at the Google Finance page and you scroll a little bit down, there are several data. For example, here we have the financials. And if we open this stuff, we see graphs and we also see some tables with some data. And for example, we say, okay, we exactly need the cash flow data from one specific stock. And I will try to show you a super simple way how you can extract exactly this data for the stock you need in as few lines as possible. So first of all, we need some libraries. With the first library, the XML2, this allows us to read in HTML files in our R. Second, we need the RWest package, which allows us to extract tables from the loaded HTML files. Next, we need the dplyr library for chaining some data operations we need later on. And last but not least, we need the string.r package, which allows us to manipulate strings in the file. So in the first step, as I told you, we decided to use the Apple ticker, and we just want to make our URL dynamic so that we just have to change our ticker symbol and we can download data for each different stock we want. And by doing so, we can start with the actual code. First of all, we have to download the HTML file itself. And therefore, we just need the command download file, put in our URL, and give the command a destination where we want to save the HTML file. Doing so, we have downloaded the file, and in the next step, we can read the data in our R script. And this is exactly when I told you the XML2 package, which allows us to reach HTML files. Doing so, I can show you saved in content. We get a super useless HTML file because it's not saying anything, or we can't extract any useful information from it. So in the next step, we have to find the tables we need, and we can do this by scraping for actual tables. And we can achieve our goal by, on the one hand, say we want to extract HTML nodes with the description table and actual HTML tables. And doing so, we see in a test1 variable, yeah, we're getting much closer. So now we see we have a list of 3, and in this list, we see we have 3 tables. So now in the last part, also if I print it, we can see it, we have the information we want, but we don't have it in the format we want, and we have all 3 tables, and we want to get the 1 table we actually need. And there, I would say the playing around part comes into play, because now we have to find the table we actually need. And there are most likely hundreds of ways to do so, but in our example, we decided to look for an argument which is unique in one of the 3 tables or in the table we need, and search it. And this we do with the command string detect, and we search for the term or the string cache from. As when we watched on the internet, we take a closer look, we see cache from, and the other tables do not contain a term like this. So we know if cache from is into the string, we know it's the table we want. And therefore in our code, we just write a small loop where we say if the term cache from, the amount of, when the term cache from occurs more often than 0 times, then save it, and also save it as a data frame. And by doing so, we not only extract the right table, but also bring it into format we want. We saved it in cache flow. So I can show you, we get exactly the data we wanted in a not super format, but in a format we can work with. And I think all of you are able to manipulate data in a way that it looks proper as well. But that's not my exercise today. Good. And lastly, I want to show you a way to work with APIs. And therefore, we use the Yahoo Finance page. And we have to know APIs basically are files like JSON files, which are feeding the actual website. So if we go to the Yahoo Finance page, for example, we use the ATX ticker, so the Austrian Traded Index, and we say, okay, we have a super nice chart, but we want the data which are lying behind this chart. So we want the actual stock prices at a given time. And so doing this, we have to find the API behind, and we have to scrape this API. But in the first step, we have to find the URL of the API, because otherwise we can't scrape for it. And just do a little refresh that we have real life data here. And we can do this the following way. Okay, short connection troubles. So now it works. By doing a right click, we have the option Untersuchen in German or investigate. By doing so, it opens the window of the source code. Looks pretty ugly, but it's not that hard. In the headline, we see some different options. If we go to network, we open the different processes running in the background. If we go here in the headline to the option fetch or XHR and order it by the size. Okay, let's refresh again. They are not reloaded. Perfectly. Now we see we get live data. All the processes are loaded right now. And we go to the top, to the biggest one. At some point in the top, we find something or some term which includes our ticker itself. So we see here the ATX with a lot of more commands. And we see, okay, that's exactly what we have here, our ATX. If we click on it, we get the full URL, which is exactly leading us to the API we need. If we copy this URL and type it in, we come to a page looking like this. So a pretty ugly JSON file, which includes all the data we need. So I think it's about 6,000 lines of full with data saved in a JSON file. So now you know how you can get to the API itself. So now we have to load this API again to our R script and scrape in this API and extract the data and bring it in a format where we can work with it. And I want to show you in a pretty quick way how, for example, you can do it. Again, there are many ways how you can proceed to do so. In the first step, we need the rwest package to read HTML files. Then we use the string E and the string R package as we work with strings again. We use the curl package to connect with HTTP queries. And in the next steps, we also use the LabRedate package as we have some dates. And again, the dplyr package as we manipulate some data. Again, we want to make our URL dynamic so that we can change its parameters as quick as possible. So as I told you, we use for the example here the ATX, and we give it a start and the end date. So we want data from 2000 to 2024 on a 1 month interval. And that's the pretty cool thing here, because you can play around with these parameters. So you can get, and we tried it, the shortest interval you can get is 2 minutes. So for all the day traders out there, if you're not willing to spend some money for intraday data, that's a pretty cool and cheap way to do so.
Simon, this is Jesse. We got a question that's related to this, maybe kind of interesting just to jump in here. This is from Thomas.
Yes, of course.
Yeah, this is from Thomas. Can there be issues with memory, RAM, when trying to locate and identify the current API in the web console? Or is it already considered in the RAM allocated to the website when it is fully loaded?
Maybe I can take this one.
Please go on.
Oh, thanks. So there shouldn't be, unless you try to go for, let's say, much shorter intervals, like 2 minutes, as Simon mentioned. But on the other hand, the 2 minutes intervals are limited by the source itself to 2 months of data. So if you take currencies, for example, which trade 24/7, then you get, I don't know, maybe 40, 50,000 data entries. So not even that is going to kill the ROM. I agree with you. If there were a possibility to download, let's say, 2 minute intervals for the past 10 years, then you're going to run into some serious issues. But kind of the way Yahoo Finance is set up and the API is set up, it only allows for the 2 minute interval for the past 2 months.
All right, thanks, guys.
Exactly. Maybe adding to this, we also see if we are on the actual Yahoo page, if you go to intraday data, so to shorter intervals, you can go that far back in time. And that's exactly what Goran told you. So if you go in shorter intervals, you can't download more data, I think, than 2 months. And yeah, that's exactly the reason. And therefore, there shouldn't be no problems. Exactly, yes. Where did we stop? Exactly, we want to create a dynamic URL again. And for using APIs on Yahoo Finance, therefore, we need to know that these APIs use date formats in POSIX format. So therefore, we also have to convert our dates into POSIX dates format. And then we created our actual URL that we also got from the source code I showed you before, just in a dynamic way. So having this done, we can start with the actual web scraping again. So if we use our read HTML command again, we can read in our file. So showing you the test2, we have again a pretty useless HTML file because there is no good information for it. So again, we have to try to extract the content we need and separate it by spaces. And this we can do by the HTML text2 command to extract our content, and with the string split command to separate it by spaces. And doing so, I can show you the result. If we print the test me variable where we saved it, we got a super long string with a lot of numbers, which maybe are our stock prices. And if we scroll a bit up, we come to a place where we say, okay, that could be the POSIX date formats. So we see we have loaded the data we need, but the format is pretty ugly. So now we have to find a way to bring the data in shape, and therefore it's again a bit the playing around part. So we have to go through these long strings and find the spots where we want to start to extract data, and to give them the right descriptions. And therefore, we did a lot of string manipulation and data manipulation, which I do not want to show you in detail because it would take too much time. But as Goran told you, all the code is available on JIT. So please check it out. But by doing so, I will do it this way. I can show you saved in final data set. We are able to to create a data frame showing us the dates with our closing prices. And if we want, in the next step, we can also separate the date and the time so that we have a pretty proper table which allows us to properly work with it. And also to show it visually, we see a pretty nice graph of the ATX over the past 24 years with monthly intervals. Exactly. And doing so, I hope I could show you 3 different ways how you can get live data from the internet by doing some different kinds of web scraping, and how you can use this data and create nice R Shiny apps and deploy them. Goran will show you in a minute.
Thanks a lot, Simon. So I'm gonna, if you just stop sharing, so I can start on my end. So perfect. Thanks a lot, Simon. Let's continue from there. As Simon mentioned, these are really the, let's say, most convenient ways to get the data that we need, if we go back, that we need for our inputs here. So the question is, of course, once we get this data, and of course, there is a lot of processing around it. So we need cash flow data that Simon presented for different companies to create, let's say, peer groups. We need interest rate data for different markets to extract the market risk premium, because that's the basis for a cost of equity that we have here. So all of these parameters that you see mentioned are embedded in what Simon presented to us. So the next step would be, once we have this data, to actually start modeling with that. So let's assume, as you can see here, let's assume that we extracted the cash flows and the volatilities of cash flows of different companies that we own, let's say, and those companies that don't even have to be stock listed, so it can be also privately owned. But in any case, we need the volatility information of stock listed companies because that's the only information that's available. So once the data from Simon has been brought into the right format, you would have, let's say, in your database, something like this. So for every of your holdings, for every of your participations, you would have the information coming from an independent valuation around the value of the company at a certain point in time. And you would have the starting values more or less to start your simulation. And then you need to enrich it with the information that was presented by Simon, meaning volatilities of cash flows themselves from peer companies. You need to define the peer group so that you know from which companies you need to extract data from the web. And you need cost of equity information. And cost of equity, let's once again stress it out, is basically the market risk premium that Simon presented before. So returns of a stock index above the interest rate, the risk-free interest rate. So that's the market risk premium, plus the risk-free interest rate, plus some different premia of a company. So that's how you get to the cost of equity. So all of that can be actually obtained through scrapping. And in this case, you would have this input that we are showing on the left-hand side, on the top of the left-hand side. So that flows into the model itself and is getting combined in a decomposition or reverse decomposition in order to actually combine different cash flow values and cost of equity values with their volatilities. So what you actually do is, if you say your company A is worth 7 billion and has a cash flow of 5 billion and a cost of equity of 12%, then you would actually want to simulate those variables. And you can only simulate if you have volatilities available. So the volatilities is exactly the outcome that Simon presented to us. So once you have those variables, then you can run the model that is mentioned on the left-hand side. So you would calculate the non-correlated part. So assuming that the participations have nothing in common. And then assuming that the cash flows and cost of equity variables are somehow correlated with each other. So by doing so, you can actually get to the distribution that you have here of values of your portfolio, which is non-diversified. And why I'm putting an emphasis on this non-diversified is because you're lacking information on correlations of different peer groups, sectors. Let's say sectors, industries. So how do you get information on correlation of different industries? I'm going back to what Simon said a couple of minutes ago. You would get the, let's say, Yahoo data from, let's say, Standard & Poor's index on utilities, consumer staples, industrials. So different sectors of the index, you can actually download the values of these sub-indexed compositions and have them here presented in a matrix. So this matrix that you see here, this correlation matrix, is also the outcome of web scraping. So if we move on, what do we do with that data? We create a user interface through Shiny and a model in the background. So this model in the background, we already tried a bit to present, but we will go into the details. But the more important thing is we create actually a user interface for it where you can calculate it and save it. So what we have done also for you, and you will find it in the link that our consortium just shared in the comments, you will find a fully functional application that we're about to walk you through now and to present to you. So let's maybe get into the details of it. So what you see here is a fully functional application for quantifying participation risk actually coded for this purpose only. So you can use it freely. What it does actually is you can upload the input file which I presented to you, which is the result of what Simon has presented when scraping the content of the web. So what we have here in this input file is actually exactly the information that was on the slide before. So we have our companies that we hold, we have a bit of the valuation, the initial valuation, and we have the different cash flow volatilities and cost of equity volatilities. So that's it. And then if you kind of upload that and start the model, what the model does is what was presented a couple of minutes ago. It combines the different holdings. It calculates a portfolio of those companies simulated in their values. And here, of course, for the purpose of this presentation, I have just performed 300 simulations, because otherwise we will wait until tomorrow to get the result probably. So 300 simulations. So don't overinterpret the result, of course, here, because it's not pretty much diversified. But what we have done now was simulating the market value of those 6 companies I think we have in the portfolio over 300 points in time. So let's say 300 years. So out of those 300 simulations, we have combined the values, the market values, based on the correlations of the different sectors. And the sectors we can actually see here. So we have used a company that was based in the food and beverage sector, banks, industrials, and so on. So that's, again, data from web scraping, what Simon just presented. And based on this data, based on these correlations, you can actually calculate 2 values. The one value as if you simulate without any correlation at all. So out of a portfolio of, let's say, 1.7 billion, you would get a risk of 9.9 billion, which is 58%. So value at risk, non-diversified, 58%. If you combine it with different correlations in different sectors, you arrive at 750 million roughly, or 44.5%. Over 1 year, 99.9%. On the bottom, you will see the different companies actually with their valuations, with their value at risk, diversified, non-diversified, and all the details around it. So what you also have here, and why we have put it as a function into this tool, is you can save your results and use them for reporting purposes. So again, we are not, of course, presenting here a fully functional tool for, let's say, the purpose of a bank. We are just showing you how this could work. So we tried, of course, to put as many functions as possible in here. So what you will find here is a save function that creates a database in the background and saves the results of the simulations. So in the end, if you want kind of to do a bit of reporting and then statistics, you can then, for example, say, okay, I'm connecting to the database itself. I'm selecting from this risk participation database, and I want actually to see what is in there. So if we do so, we can actually see that I already did for you, and you will find this information online. I did 2 simulations on the 26th of November and today, and with 2 different results, with 2 different value at risk, or 99.9% interval on 1 year. So it's just, again, simplifying, because I know we have a limited time frame today, but a bit oversimplifying the results. This would be something that you would find in a report directed towards senior management to explain where your value at risk is on a certain point in time. And then potentially you would also add the positions that are also driving this value at risk. As mentioned, the tool is fully functional and available to you. It's under a license, an MIT license. That means an open license, which means for you, use it, share it, ask us if you want some additional information on it. because the source code of it, as you can see here, contains details that are in the slides. So if I may, for example, present this part here, that's talking about how we combine the correlation between cost of equity and cash flow through a correlation factor using the reverse Koleski decomposition. So that might look straightforward on the slide. In the R script, it looks maybe a bit different, but I tried actually to put also the references to it, same as Simon did, to give you the explanations behind it so that you can find the reference between the slides, what we mentioned there as a model, and to the source code that is mentioned here. So, however, with this tool, the whole journey does not stop. We have the final step, and that's more or less how do we deploy the whole thing? Because let's face it, if you can get the data, if you can produce a tool as you now have it in JIT, if you can use this tool, you potentially will not use it on your own only. You will maybe share it with somebody, maybe a whole team will use it. So it makes sense to leave, let's say, the R studio environment that Simon and I were presenting today, and it makes sense to maybe put it on a server. And as you can see here, we have prepared a couple of steps to do so, best practice actually, assuming, and that's very important, assuming that you avoid buying a third-party solution, and assuming that you're not in the cloud, because that would make probably some things more complex, especially in the banking world where you have strict regulations. So let's assume you buy a server, you have a server, an in-house server being hosted internally. So you would take as a first step your application that you have on JIT, and you would copy it there. So that's kind of, in addition to buying the server, the second step, you would have the application.r file or application in itself. And in addition to that, you would create a connection file. I will show you in a second. And what the connection file does is it links your server address to a port. So meaning, what is the address? What is the name of your application that you call it? Meaning, how can you access it through a web page on the intranet in your own network by using what address? So that's what the connection R file is doing. And then you have two possibilities, either through Microsoft IIS as a service or through a connection file in the BAT format where you make it executable. So that means, let's say, long story short, you have a BAT file that you double click and then something happens. And if you do it in a server, the BAT file runs in the background and makes something available. So that's kind of the quick journey, but let's maybe dig deeper into it. I know that we have limited time, but maybe just a couple of keywords here. We have in our app file all the details that you need for deploying the application. So you have a user interface, you have a server part, you have a DBI connection inside. As I said, the database has already been created for you. You have dialogues used so that you can actually interact with the tool itself and get information when something is done. You have the dashboard combined with the calculations. So you have noticed when I clicked on the button, it was actually giving me the feedback that something's been calculated and then displaying the calculation immediately. So all of that is actually created through these steps that I explained before. So you have your source code that we provided to you. You would only have to create a connection.r file, which, as I put here in the source code in the last line, would have your host, meaning your server address, mentioned. And then you have a port where you deploy it. So let's assume 127, I don't know, 25, 25, 27 would be your server address, and then you would add the host or the port, sorry, to the host, which would be the full internal address for your tool. And then in the final step, you have the bat file that would actually only connect, or not only, but it would finally connect your connection file to an executable web, meaning you will show your application on the web under the address of the host plus port. Intranet, that's important. Intranet. That's the final outcome. So as you can see, you get the tool displayed online, not just kind of on the RStudio environment, and everybody can access it. Meaning, if you have a team, if you have a larger team that has the need to actually run those calculations, you can use this approach in order to have a fully integrated tool for calculation. You can actually build in the content that Simon provided as a separate file to scrape the data and get data. So you don't need the Excel files that was just used to fasten up the process now to present to you the product. But in the end, you don't need it. You can scrape the data actually from the web, and you can connect to your own databases for initial values. You have a dashboard. You have the database that we mentioned. You can embed, as you noticed on the left-hand side, you can embed your own handbooks or any additional information for governance. And I know it's no longer probably needed, but still some like the functionality of downloading to Excel. So for us, it was a line of code, so we provided this function too. So if you need to share kind of the results of the calculation, you can do it by having the function of downloading to Excel that we presented to. So that is actually it from our end. I'm giving back to our consortium, also to you, of course, for questions and comments, and happy to answer them.
That's great. Thank you, Goran. Thank you, Simon. Super detailed and very interesting presentation. Anyone who would like to ask a question can use the Q&A icon down at the bottom of the screen and type in your question. Now, we have a couple that have come in. I'm going to get to these right now. So from Jennifer, it says, I believe this is directed at Simon. You indicated there is a playing around part to get the formatting right. How much time did this take as a percentage of the overall effort?
That's a good question. Yeah, it depends. In the first example I showed where we scraped from the Google Finance page, it's pretty simple. So we just have to find a part in the string which is unique, and go for the string, search the string, and extract this part of the entire HTML we read in the R file. In the second example where we worked with the API, I think it took us 1 or the other hour, because you saw it in the code, or you can see it in the code. It's a lot of indexing, a lot of finding the right part in the HTML file, and then also finding the spot and the signs you need to extract the part you need. But there is no answer for 1 minute or 10 hours. I think it depends on the R skills and also on the task you actually have. So, but for Goran, it's 10 minutes. For me, it's 5 hours. So to say.
Got it. Okay, here's another one. This is from Sheila. To get the API from Yahoo Finance, no extra tools other than the dev tools in the browser are needed?
Exactly. So for Yahoo Finance, it works. So with the way I showed to you, also maybe you need to know, for us it also was some Googling and researching how we can extract it from the source code. But in Google Finance, you find it for every different stock or every different data you want to know, by doing as I showed to you. For some other websites, I can tell you. So a little bit of research and a little bit of trying out, but there are many pages where you can find these APIs.
Great. Okay, if no other questions are coming in, Yeah, I'd like to give another thank you to Simon and Goran, and also from the R Consortium, the people who joined and participated. We give you a big thank you. The full recording of the webinar will be available through the R Consortium website, and we've put the link for the repo that was demoed today, but that will also make that available. I'm assuming I'll check with Simon and Goran, but we'll make that available on that same page that has the webinar information.
Absolutely. Feel free. And thanks a lot for inviting us. It was a great privilege talking to you in front of you and to all of you about our experience with modeling risks. So if you have any questions, Simon and I are available. You have our contact data in the presentation that I assume will also be shared. So we will make it available under the JIT link, and looking forward to hearing from you.
All right. Thanks, gentlemen. Thanks, everyone. Take care.
Thanks a lot. Take care.
Thanks. Bye.